It's a monitoring alert notification routing system. But I just wanted to be upfront about this, which is that I am a little bit on edge from being woken up at 2 a.m. in the morning before this particular talk, so I apologize if I'm a little bit sketchy on some of the details. All right, so what is Flapjack? Well, very simply put, Flapjack is a monitoring alert routing system. So you can think of it as an extraction of a lot of the alerting and notification stuff that you have in tools like Nagios that are surprisingly well developed, at least the notification side of it, except that it's sort of sitting in an external system. And there are a couple of really key advantages that you get with pulling it out of something like Nagios and putting it in its own system. Firstly, it's completely composable, so you don't just have to talk to Nagios, you can talk to Asingo, which is basically Nagios, but also Sensu. It's very easy to push events to it from different places. Flapjack makes a couple of assumptions about how those events are structured, but we'll go into that a little bit later. Additionally, it's got rollup. We sort of call this alert summarization, but Flapjack has support for rollup and alert summarization out of the box. It's very easy to set up and configure. And just alert routing in general. So we have fairly complex logic about how to handle routing alerts from some sort of technical system to a person, like that can actually act on that information. And the way that Flapjack works is actually really, really simple at its very core. So everything in Flapjack is an event. Event information is coming through. When Flapjack sees that event, it goes, okay, do I actually need to notify somebody about this? If so, who do I notify about this? And how do I go about notifying that person? That's it. That's pretty much all that Flapjack is doing. It sounds very simple conceptually. Obviously, there's a lot of depth to that and a lot of nuance, and hopefully we get to a lot of that in this particular talk. Flapjack is also API driven, so any changes that you want to make to the data within Flapjack can all be controlled via an API. In fact, have to be controlled via an API. We have a web interface that exposes a significant chunk of the functionality provided by the API. But the idea there is that you don't have to restart every single time you want to make a configuration change, which I know it's like totally crazy talk. So we've been using this at Bulletproof Networks for the last almost 2 years now. We sort of rebooted the project back in mid-2012. It's developed primarily by Ali, where's Ali? Ali's just down there, and Jesse, who's just over here. And you can see, having nice long walks on the beach and frolicking and that sort of thing. I'm sort of like the project manager for this, but you can see me as the face, but they're really the neck, and without the neck I would be some sort of chinless, necklace freak. So they're really the guys that are getting shit done and making stuff happen. So Flapjack is written with a bunch of really simple technologies that are sort of well-known, proven. We use them in a lot of other places as well. I was just using plain old Ruby, and it's C-Ruby, Ruby 1.9.3 at the moment, and just Redis, that's it. Very simple. There's not a whole lot of stuff that's happening here. And fundamentally, we're trying to design a system for humans that sort of acts as an alert umbrella. For all the alerts that are coming through, we want to protect the operator and stop them getting soaked when you have some sort of major outage. So yeah, we're all about making humans feel happy about having to be, well, less sad about having to be on call. All right, so there are a couple of key cases that the Flapjack is really going to help you out with, and some of these may apply to everyone, some of them only do a couple of people. So those specific use cases are, firstly, you have a very large number of potential contacts of people that you might actually want to notify. So a really good example of that is, say you've got like a dedicated on-call team that is receiving notifications with PagerDuty, but you also have other people within your organization. You're a slightly larger organization, or you're a service provider. You want to provide more informational alerts to them. Flapjack is a really, really good fit for that. So at Bulletproof in particular, we have about up to about 4,000 individual people that could be notified at any point in time by our monitoring system. Obviously, maintaining a Nagios or a Sensu configuration for 4,000 people is sort of going to get complex quite quickly. So that's part of the reason why we decided to build Flapjack. It's also multi-tenant as well. So again, back to that service provider example, those 4,000 people, in our particular case, they don't all come from one company. There needs to be strong segregation between those different customers. We want to make it easy to be able to query across multiple customers at the same time from an operational perspective. But it's very easy to push all of your notification settings into one place and have Flapjack handle that all for you. It's pretty useful. It's also very useful if, again, like I was saying, if you have some sort of segregated responsibility within your organization. So you've got dedicated, like going back to the first example, you've got a dedicated ops team that's looking after like an entire platform, and they're the guys that are on call, guys or girls. And then you've got like a product team that are, the platform is made up of multiple products, right? And they don't really want to receive all the notifications for everything that happens on the platform as a whole. They just want to see stuff specific to their particular product. And Flapjack makes that, again, very, very easy to do, to sort of target the particular alerts that you're interested in actually receiving, and making it easy for self-service monitoring, alerting configuration, which is pretty useful. We also try and play extremely well with other people in the ecosystem. So I sort of mentioned before that we have PagerDuty integration there. One of the interesting questions that sort of keeps coming up more recently is, well, how does PagerDuty and Flapjack sit with one another? We actually see each other as being very complementary. We are really big PagerDuty customers. We love using PagerDuty. PagerDuty is solving a different problem fundamentally to what Flapjack is doing. PagerDuty absolutely excels at the likes of escalation policies and rosters. Flapjack doesn't really have a lot of that stuff baked in. You can totally make it do that if you wanted to, but for our particular use cases, it's more, think of it as a Venn diagram with the two different technologies overlapping slightly. There's also check engine independence as part of playing nicely with other people as well. So you can run multiple check execution engines like a Nagios, a Singa, a Sensu, all in parallel, but you have a single pane of glass that ties all of that stuff together. So one of the other interesting use cases that we're seeing with people that are deploying Flapjack are that they actually just use it as a very simple way to get an overview about all the different things that all the different monitoring systems that all the different teams have got. So for dashboarding and things like that. So that's pretty cool. All right, so to get started with Flapjack and sort of dive into the meat of this particular workshop, we ship a Vagrant box called Vagrant Flapjack, which makes it very easy to get up and running locally and test it out within a matter of minutes. So you add a Vagrant box, you do a git clone, you Vagrant up it. That's it. And at that point, you've got the Flapjack web user interface running on port 3080, and you've also got a couple of check execution engines that we ship with that Vagrant box as well. So we've got Nagios 3 and a Singa on port 3083. So we've got it over here, it's working, and we can see here that, yep, everything's great. Okay, so let's dive a little bit deeper. Ooh, lots of fun. So the first thing that we're going to do here is we're going to simulate a fail check. So we're going to do this particular thing called a fail and recover check. In fact, you know what? Rather than going through the slides, I'm just going to do it. So we're going to simulate a fail check here. We do a -- help. That text is sort of big, isn't it? Let me move this stuff out of the way. Can you all see that up the back okay? Yeah, great. So it doesn't wrap. So simulate fail check has got two different commands that you can pass to it. There's a fail and a fail and recover. So you can probably work out what those do, but fail will basically send a stream of failure events to Flapjack for a particular entity or a check in a particular state. And fail and recover will do exactly the same thing, except the last check that it ends up sending through last check result that it ends up sending through will be a thing saying, yes, everything is actually back to normal. So it's a pretty useful test after you've got Flapjack up and running to sort of just see how things actually work. And funnily enough, the simulate fail check command is also very useful for doing any sort of load testing. So, I've been doing a fair amount of load testing in the last sort of week or two. So with the timing on that, you can see here there's an interval setting here. We accept decimals, so floating point integers, so floating point numbers. So you can fire up multiple of these in parallel and actually pump lots of events through Flapjack and see how it actually performs under a whole bunch of different situations. So what we're going to do here is we're going to run simulate fail check. We're going to fail and recover. Make that a bit bigger for everyone. We're going to do this for a minute with an interval of 10 seconds, and we're going to send a result for, sorry, we're going to send an event for foo apo1 and a check called sausage. Okay, that's it. We're sending some events through. And as you can see here now in Flapjack, there is one of one entities. So Flapjack is recognized there's a new entity that it hasn't seen before. We can click through here. There is one failing check, so you can see the entity. There's also a bunch of search functionality there, which is pretty useful. Right, and let me resize that. It doesn't wrap too well on the small screen, does it? All right, so if we click through to that check there, you can see that the current state is critical. It's actually in scheduled maintenance at the moment, so that's sort of like a scheduled downtime. Now, the reason that that's doing that is because it's automatically created for a new check. And we do that for a very specific reason. So you can see down here that there's a scheduled maintenance period and it's been automatically created. You can end that once you're ready to take that notification live to someone. You might notice that duration there. And you can sort of think of that particular behavior that we're observing there as like check provisioning quality control. So quite often when you're doing sort of development on your monitoring checks and configuring stuff for your infrastructure, you're going to be messing about with a bunch of different checks and you're going to have failures and you don't want that to notify people immediately. You can sort of think of this as a grace period for all those notifications that are going to be set out, and that's completely configurable as well. So we have this new check scheduled maintenance duration setting in the Flapjack configuration file. The default value is 100 years. However, you can change that to be whatever is appropriate to your organization. You can also completely disable that as well if you happen to live in a magical world where you provision monitoring perfectly every single time the first time. Yeah, and again, this is about providing an alert umbrella for the operators and helping them out so they don't get drenched whenever it starts raining. Okay, so for talking about how Flapjack works, I'm going to hand over to my colleague, Jesse.
How you all doing? If anyone's got any questions or things, just shout out, wave your arms in the air, something like that. Okay, so how does Flapjack work? Let's look at the data model. Sort of at its core, I guess, it's about contacts. So that's anyone who wants to receive alerts in the system, or perhaps doesn't want to receive alerts, but somebody else does want them to receive alerts. Contacts have multiple medias, so that can be SMS, email, Jabber, and PagerDuty at this time. And contacts have notification rules which act like filters in email or something like that to control sort of when and what you want to actually get notified about. Contacts have entities, so an entity can correspond to a host or a switch or a SAN or any kind of object that you want to have checks against. And of course entities have checks, which is the actual sort of pithy part of the puzzle. And we store history also in Redis, so schedule maintenances, acknowledgements, and all state changes for all checks. So you can go back and do reports on availability and so on. So drilling down into contacts, I'm just going to flip over to the web interface and show you how you can add a contact. If we go up to contacts, and yes, this screen really is quite small. Well, that's been said a few times while we're here, and it shouldn't be much of a surprise. Okay, so we're going to add a contact. Let's add Jane Doe, just to be highly original. So we've given an email address to Jane. That's the email address that Flapjack's going to use to send notifications. We can also put in a Jabber address or an SMS address here. PagerDuty is a little more complicated. It takes currently about four fields, and we haven't built the UI for that yet, but that's coming. Interval. is how often to get repeated notifications for a failing check, for each failing check. And roll-up is synonymous with alert summarization. So if Jane has any more than 3 failing checks at a time, then Jane will just get one email every 15 minutes with a summary of what's failing, rather than a whole sort of flood of messages. And you can set those numbers to whatever you like. Interval is in minutes. And we're going to select the entity which was created when Lindsay ran the simulate failed check just before. So we're going to select that entity. That's an interactive search field, add entity, and create the contact. Okay, so we've created a contact for Jane. Just flip back here. And yep, a few screenshots in case that demo completely blew up. And so if we look at the architecture a bit more, at the top we've got event producers which are executing checks and generating events. And the events get processed by processors, and the processors work out who to notify when and send those notifications on to a set of gateways. So drilling down to the event producers, these, for example, could be Sensu or Isinga or Nagios at the moment. It's pretty simple to write event generation plugins for monitoring systems, for composable monitoring systems, I should say. So these are generating. So these have got plugins or components within them each. The Flapjack feeder is the one that we're going to look at in Isinga, which is going to generate events. They're going to be consumed by the processors. You can use it in Nagios as well because they're compatible at the moment with version 3 of Nagios anyway. So this, in the Isinga configuration, we're going to add this line to the configuration and restart Isinga. And so what this is doing, it's basically saying that's this is a Nagios event broker module, Flapjack feeder, which is just some C code which is compiled to .o file, and some configuration for it. There's a Redis host is on localhost, and the port number. It should be fairly obvious. Okay, looks a little bit. Okay, so there's the line in the Isinga configuration file. Just going to save that and restart Isinga, and hopefully, if we go back to Flapjack, we will see some more entities being created. I didn't restart it. I did restart it. It is indeed. Thank you. So we've got localhost here, which is the checks that have just been created in Isinga. Yeah, so shows the last state change and the last update time. So if you look at last update time as I refresh, you'll see that it's basically updating every 10 seconds because that's the schedule that Isinga is set to run each check on. So that's all working. We're now connected Isinga to Flapjack. Just flick back here. Okay, so what is an event? So Isinga is generating these events once every 10 seconds for each of those checks, load and so on. An event it's just a blob of JSON. It looks roughly like this. There's a few more fields that are optional. Entity is just a string, so that's usually a fully qualified domain name of a host, or you might have a different naming convention for network switches or what have you. A check is just a string. It can be anything at all. Tags are optional, but they're useful for filtering afterwards, so that you can tag a check with some unique string, and then in a notification rule for a contact, you can say that they only want to receive checks that contain that tag, or they don't want to receive checks that contain that tag, and so state. It can be one of OK, warning, critical, or unknown. So that's the state that the check is in. A timestamp, which is an integer. It's just a Unix timestamp. And some summary text, which is the actual output of the check, which we display on the user interface so people get more information about what the problem might be with a failing check. So the command Lindsay ran earlier for simulate failed check is up there on the top right. That generated an event that looked roughly like this in JSON for foo apo1, check sausage, etc. The Unix timestamp. And I'm going to hand it back to Lindsay to go through the rest of the architecture. Any questions on that stuff so far? Yeah. Is it using Redis as sort of a queue, or is it? Yeah, that's right. We're using Redis for kind of everything at the moment. Yeah, we're using just lists and Redis as for queues, and there's a bunch of different queues. There's the event queue for so the event producers basically just add something to the event list in Redis. But then we use other lists within Redis for communication between the different components, like notifications and so on. Okay. Oh, yep.
I'm sorry, I didn't notice if you mentioned, but when you were showing the loadable module into Isinga or Nagios, can you load that into multiple instances and use this interface to federate output from them?
Yes, exactly. Yep, you could in fact run Sensu, Isinga and Nagios all be feeding in. At Bulletproof we've got 3 Nagios servers that are feeding into Flapjack at the moment. So we've started sharding our Nagioses. And yeah, that's sort of one of the reasons why we wrote Flapjack, is so that we were more able to move to a different check execution system and have it all work together. Is there another question? Yep.
So for names of the states, you use OK, warning, or critical. So do they represent the importance of the event, or do they represent the state of their object that you monitor? Or you say that these are pretty much the same thing?
So the question was for the check state, we use OK, warning, critical, or unknown, and is that representing the check state or the importance?
Yes.
Well, both. It's sort of it's based on the model of OK means what it sounds like. We've got 2, and then there's like 3. There's 3 categories of problem alert, I suppose. There's warning, critical, and unknown, and we do different things with those. So you can say, I only want to receive emails about warnings, and I want to receive SMSs and emails and PagerDuty about critical problems, and maybe I don't care about unknowns. Or
It's mostly not the state, but the importance of their event.
Well, it's both, because that's what Flapjack decides whether something is in a failure state. So a failure state is any of warning, unknown, or critical.
Okay, I'll follow up with you later.
Okay. Yep.
Are you recreating the entities in Flapjack, or basically pulling that in from whatever?
Okay, so what we've shown you here is we haven't created anything, we haven't preceded anything in Flapjack at all. It's just it's inferred it from the events that it's received. But there's an API which Lindsay's going to sort of touch on a little, but lets you create entities beforehand and contacts and everything they're interested in and so on. Okay.
All right, thank you, Jesse. All right, so then down to the processing layer. So this is where all the magic in Flapjack happens. So there's actually 2 different types of processors that in Flapjack that are chained together. There is the processor and there is the notifier. So the processor is pushing information to Redis, but basically all the processor is doing is it's reading events also out of Redis. It's updating states, so things like the counters, event history, any sort of maintenance schedules, that sort of thing. And it determines if a notification should be sent. It's communicating primarily with Redis to keep track of all that state and all of that history, which means we sort of end up storing a whole bunch of interesting information that you can sort of query later on to ask interesting questions about, you know, how things have alerted in the past, which is actually pretty useful. So once the processor has processed the event, and it asks those three questions that I just sort of mentioned at the beginning there, which is, you know, does this particular thing represent some sort of failure? Who do we notify and how do we notify about it? It dispatches to the notifier that determines the who and the how. So the notifier is basically sitting there and it's reading notifications, again via Redis, all these different components that you see here in this diagram are completely decoupled from one another. They talk to one another via Redis. So it gives us options for substituting different components in over time. And the notifier is just sitting there routing notifications, and it's dispatching alerts to the gateways, which are the last thing in the chain of Flapjacks. Or maybe the stack of Flapjacks is probably a better way to describe it. So how does routing actually work? Like, I've sort of talked about this and alluded to it and how it's like the most amazing feature about Flapjack, but let's actually have a look at how it's working behind the scenes. So all the way up in the processor, you have this event that's coming through from some sort of check execution engine, and the processor is applying a bunch of filters to that to find failing events. And at that point, you've dropped from the processor and gone into the notifier. So if the processor decides that, hey, this particular thing is failing and I do need to send some sort of notification about it, we create this notification event. At that point, the notifier starts asking all sorts of questions about the existing data that you put into Flapjack, like who is actually interested in this entity. So in this particular example, we've got Alice, Bob, and Carol. And then you find the media that are owned by those people. So, you know, Alice has got email and SMS, Carol has just got an SMS, Bob has got email and SMS. And then you delete media based on tags that they've registered interest in with the notification rules. Also the severity and the time of day. So, you know, we've got support for saying, you know, I only care about these particular alerts between these particular times, you know, business hours or after hours or, you know, whatever works. You know, regular maintenance windows if you have to still do that. And we also delete media based on black holes, and black holes are a special type of rule in Flapjack that are sort of interesting, and we can talk about that later if anyone is keen on talking about that. And then we also delete media based on the notification intervals. So in the example that Jesse was giving before with the email is going to be sent every 15 minutes. So if the notification, if Flapjack has decided that somebody needs to be notified about it, it'll check to see whether what the last time that person was notified on that particular media. And if it's within the window, it'll just delete it. It'll just drop that notification on the floor. So at the end of this, Flapjack has spat out a bunch of alerts here. So you can see it's basically a series of like maps and reducers to that event data that's coming through. And it's decided that it needs to it doesn't need to email anyone. It needs to send an SMS to Alice and to Bob separately. So to work with notification rules, we sort of take this approach with everything that we build in Flapjack, which is that we build everything API first. We sort of add the user interface as a secondary thing. For better or worse, we're optimizing for the flexibility and the ease of integration into people's existing environments. So for working with notification rules, currently you can do that really easily through the JSON-based API. So it conforms to the JSON API specification there. So to look a bit more closely into what's happening, the entity here is saying that this particular notification rule for this person, which has got the contact ID of 5, but it doesn't have to be an integer. It can be anything. And we're also saying that this particular notification rule will match any entities that are coming through that match this regex. Also these tags, and there's also the concept of regex tags as well, which we can talk about a bit later. You can apply arbitrary time restrictions, so it's all very, very well documented throughout the JSON API about how you actually make that work. And there's different media here for warning and for critical and for unknown. So you can see all the JSON API documentation. Ali has done a fantastic job in the last couple of weeks building that up. It's exhaustive. It also makes building clients and integrations with existing tools that you've got very, very easy. We built Flapjack in this way from a bulletproof perspective because we have our own customer portal that we want to integrate and display all of these notification rules and manage contacts and whatnot alongside. We're just talking to the API to be able to to allow our customers to do that, but the API is fully featured enough that you can do this in pretty much any sort of context. All right, the last piece of the architecture puzzle is gateways. So we've got alerts that are coming out of the notifier and they're being dispatched to the gateways, and we ship a bunch of different gateways now. So primarily email, SMS, Jabber, and PagerDuty. We've actually got the web and the API interfaces, or components, gateways. They are actually gateways as well. We don't really make any distinction between things like email and SMS and the web and API. They all run using exactly the same infrastructure. Maybe there's a slight difference there with the web and the API in that they talk to Redis much more directly, whereas the other ones that we've got down here, the email, SMS, Jabber, and PagerDuty, they're more sort of just dispatching messages to one another, whereas web and API sort of have a bit more direct access. They're slightly more featureful, right? And we've got the concept of unidirectional versus bidirectional gateways. So these particular gateways here are bidirectional, and what that means is that once an alert gets dispatched to somebody, an actual person, that person can interact with that gateway to change the state within Flapjack. So a good example of that is like the Jabber one, which coincidentally also works with HipChat pretty well. If you have an alert that goes out into a Jabber room, you can, an operator that's sitting at the other end there can talk to the gateway via Jabber and say, hey, tell me about all the things that that are failing. And it'll talk to Redis, the Flapjack's Redis, to find information about that, and they can acknowledge, set downtime, that sort of thing. Look at the overall state. So that's pretty useful. And then there's the PagerDuty integration, which works pretty much in exactly the same way. And going on what I was saying before about how we love using PagerDuty, we've actually got this pretty neat feature, which I haven't seen any other sort of monitoring notification system use, which is that when you're using PagerDuty with something like Nagios, you have this whole double ACK problem. So the operator will, the check execution engine like Nagios, let's just say hypothetically you've got Nagios talking directly to PagerDuty, and Nagios detects that something terrible is happening. It decides to dispatch an alert to PagerDuty. PagerDuty will route that to the appropriate person, and using all the awesome tools that you get with PagerDuty, you acknowledge the alert via your phone or whatever. But then Nagios doesn't know anything about that at all. So the operator then needs to go and do a second ACK. So they're already trying to just work out what the actual problem is in the first place and trying to do more investigation. But we're sort of burdening them with all this extra paperwork of like, well, actually you need to, so our SLA reports are okay, you totally need to go and acknowledge that stuff in Nagios. And that sucks. Like when I'm on call, the last thing I want to be doing is filling out paperwork. I want to be solving problems and getting back to sleep. So Flapjack actually synchronizes the PagerDuty state across. So when an engineer acknowledges an alert in PagerDuty, Flapjack will actually detect that and update the state internally. So it means that you eliminate the entire need for that double acknowledgement. And we certainly found that helps quite significantly in improving the mean time to restoration of services and that sort of thing. It's one less thing in the checklist of tasks that people on call have to do, which I think is pretty cool. So there are some other killer features that we don't quite have enough time to go over, but I can sort of cover them at a pretty high level. So in Flapjack, we've got a thing called the UberTet, which stands for the out-of-band end-to-end test. And this is a form of self-checking within Flapjack. And the way that works, so going back to this architecture diagram, we've got event producers which are pushing stuff to the core of Flapjack, like the processes, and then Flapjack is dispatching those events to this UberTed that's sitting at the other end. So to expand that a little bit, you have this service over here, like a Flapper service, and Flapjack ships a small little tool that does this. And basically, the Flapper service is just oscillating between keeping a TCP port open and closing it. Then within your event producers, say Nagios, you have a check that is checking to see whether that TCP port is open or closed. So if it's open, it's an OK. If it's closed, it's a critical. And because the flapper is oscillating between having that port open and closed, that event is going to, the status of that check is going to change quite significantly. It's going to oscillate between those two at some set interval. So the event producer is just passing that information directly onto Flapjack, and Flapjack is then very respectfully passing that through to a Jabber room. And then we have Ubertet also sitting there in that Jabber room, and it's looking for that changing in state, for that check that's going up and down and up and down and up and down. And if it notices that within a particular window it hasn't seen that flapping change, it'll actually dispatch an alert to PagerDuty. And that's really useful for identifying bottlenecks and performance issues and just pure availability issues further up the stack. So, one of the really common things that you see in Nagios, if you're doing it at a large scale, is that quite often it will just stop. It'll just stop executing checks for all sorts of weird and unknown reasons. So the flapper is like a canary for that. It makes it very easy to determine if there are particular parts of your check execution infrastructure that are not behaving as expected. And it'll just pass it through using it's a full end-to-end test, right? You're exercising the entire Flapjack stack, top to bottom. Other than that, we've also got the alert summarization, so the roll-up stuff that we alluded to beforehand. So the way that this works is that in Flapjack you have per media, per contact thresholds. So the way that works is, looking at this architecture diagram again, we have the summary threshold, which is this other thing that sits off the media. And the idea there is that different media, or different mediums, you want to do different types of summary thresholding for that. So, for example, if you've got people that are receiving SMSs, you probably want to have that summary threshold set rather low, because anything more than about 3 SMSs at any point in time does a pretty good job of freaking people out. And also, SMS networks are just notoriously unreliable at delivering messages. So you send more than 3 in a 60-second period, and quite often they bank up. So from that perspective, you totally want to have a low summary threshold for SMSs there. Email, well, we have this amazing technology in email like filtering in your inbox. So a lot of people tend to use that pretty well. So you may not want the summary threshold to be that high, but it's also pretty useful if you've got somebody that's registered interested in lots of different things that might fail simultaneously. If say you've got a traditional 3-tier web application and something explodes in the database layer, the failures are gonna cascade all the way up the stack. So you're gonna have lots of notifications that are gonna be sent out. So in those particular cases, the summary threshold in your email is probably pretty good, because you don't want hundreds or thousands of emails for every alert. But with PagerDuty, for example, PagerDuty already does the roll-up for you, which is pretty fantastic. So you can just set the summary threshold to 0, and you won't get any roll-up there, which is pretty useful. So we give the flexibility to customize that based on whatever your situation is. And the last interesting thing in Flapjack is tagging, and we've sort of done the groundwork for implementing quality tagging all throughout the Flapjack infrastructure. You've sort of seen that before with the notification rules being able to match on tags, but we really see tagging as being the future for how contacts are going to be registering interest in particular things. The main reason behind that is that when we started out with Flapjack, we sort of had this. It's not a core assumption. We made a certain assumption so that we could deliver something quickly, that there would be a direct one-to-one relationship between an entity and a contact, and that sort of assumes a fairly static view of the world, in that entities are just a thing that a long time, quite far ahead of time, that this thing is going to be here, and it stays around for a long time, and when you're going to get rid of it. Whereas if you look at running any sort of infrastructure on AWS or any other cloud provider where you're using a technology like auto-scaling groups, you have no idea when entities are going to come and go. And it's unreasonable to expect that you have some sort of human or system that's trying to constantly synchronize the state with Flapjack around events. around entities. So tagging is going to be a fairly fundamental part of how we can do the alert routing, so that when new services come up and disappear, they are also pushing tagging information, and then contacts are able to register interest in tags there. All right, there are some things about Flapjack that might actually surprise you about its design. So firstly, Flapjack assumes a constant heartbeat of events that are coming through. So this means that there are no one-off events whatsoever. So you can't, it's not like the stats-D model where you can just arbitrarily dispatch a stats-D metric whenever something happens. It's much more like the collect-D model where you're sampling at a set interval. Flapjack expects to see events that are coming in at that set interval. And Flapjack does this because it actually asks quite a different question to other notification routing systems or just other notification systems. It's asking a question of how long has the check actually been failing for, not how many times has the check failed, or maybe more subtly, how many times do we think that we've observed a failure within a variable amount of time, which is a really awesome problem with Nagios. Or any check execution engine, actually. I should totally stop ragging on Nagios. So why do we do this? Well, we don't actually have the concept of hard or soft states. We basically have implemented a sort of broadcast delay within Flapjack. We don't really care how many times we've observed something, because how many times we've observed something is relatively unreliable. It's about how long we've observed that particular thing. And that's fundamental to the way that alert summarization works. So because we basically have a buffer of all the notifications that are going out, we have this 30-second delay before things get sent out. It allows us to kick the alert summarization in and do smarter roll-up and aggregation of alerts. So finally, Flapjack is completely open source, and this is really core to everything that we're doing here. So you can find us up on GitHub here. All of our release planning is done completely in the open. You can see the documentation there about how we do all of our release planning. We have a policy for triaging bugs and features, which is sort of nice. Quite often you find that there aren't really any sort of policies around how this stuff works, and bugs are left open for literally years on end. We're very aggressive about trying to close those bugs, while also balancing that with adding new features at the same time. We use semantic versioning for Flapjack releases, so I'm sure most of you are sort of familiar with that. If you're not, you should totally go and look it up. We also write tests, amazing! So they're full unit integration tests for everything that we do. We're really rigorous about how those tests, the performance of those tests and what the actual test coverage is. We have approximately 80% coverage of the code base, and that sort of goes up and down, but we're pretty cautious about making sure that we're testing everything, which I think is probably pretty important when you have a system that's going to be waking people up. You want to make sure that it works in a predictable behavior. And not only do we write tests, we actually run them as well. I know this might amaze people, but So we do this entirely with Travis. It's completely out in the open. You can see all of the build infrastructure very easily. We also run the Travis tests on CI pulls, and that's on like pull requests when they're opened on GitHub. We're really focused on maintaining a high quality product here. So there's the Flapjack GitHub organization. Under that, there's Flapjack itself, Flapjack Dyna, which Ali is primarily maintaining, which is a client for the Flapjack API. Vagrant Flapjack, which has sort of been the basis of everything that we've covered, that we've been doing throughout this workshop, so it's very easy to get up and running, just basically git clone and Vagrant up. We use Omnibus Flapjack for building packages, packages.flapjack.io for all of the source, and like our website as well is just in the plain old Flapjack repository over here. And packages.flapjack.io, we currently have infrastructure. We build all of our packages using Omnibus, so they're fat packages, which means that they are quite large. They're about, packages right now are about 130 meg in size. But on the other hand, you install it and everything just works. So that's sort of cool. We bundle a particular version of Ruby, we bundle all the Ruby gems. We actually even ship our own version of Redis. And the reason that we do that is that we fire up our own version of Redis on its own port, so it's nicely segregated from any other Redis that you might already have on your system. And we do fairly strong checking to make sure that all these different components work whenever we're doing a release. There are debs that we provide, and you should totally contribute back by doing some RPM stuff. There have been a few people in the community that have sort of been doing stuff within their own organizations. We're here to help in building a solid Yum-based infrastructure for serving up these packages. So we spend a lot of time actually every day. Like we're all based in Australia, as you probably noticed by our accents. So we're sort of living in the future, but also at the past at the same time. So when you guys are doing stuff during the day, especially up here in North America, by the time you get to about another 3 hours or so from now, we start coming online. Jesse and I both come on pretty early in the morning, so normally when we wake up, there's a nice long list of messages waiting for us, queued up in IRC cloud and that sort of thing. So we spend a big chunk of our day every day just trying to help people out with using it. So we're really invested in trying to help other people outside of Bulletproof use it. Quality documentation, if there's bad documentation, we consider that to be a bug. If you have a bad sort of first experience, we also consider that to be a bug as well. We really like the ideals that the Logstash has around that. So in conclusion, you should totally care about Flapjack if you have large numbers of potential contacts that might be notified, you have any sort of segregated responsibility within your organization, and you want a single pane of glass to look at all your different check execution engines. And again, we're all about providing an umbrella for you during alert storms. Thank you very much. I have time for 2 questions and then we're going to go to the break. Jesse, you want to come up? Because you can probably answer a bunch of them as well. Yes, over here.
After you've been through or simulated a data center outage where you've got hundreds of machines, hundreds of varied machines with all different checks, just suddenly you're not there anymore, and nobody else is kind of right.
So as in how have we or how would you?
No,
Oh, right. So the question was, have we simulated like a really, really large-scale failure, and how Flapjack actually deals with that? Yes, we have done a whole bunch of testing around that. We aren't doing it as aggressively as we would like. One of the things that we want to do post the 1.0 release of Flapjack, which is going to be out in the next couple of days, is actually run a full battery of benchmarks on every pull request that's submitted. So we have some pretty good ideas about what the performance of it is. It works pretty well. With the way that the event processing model in Flapjack works, you do have a slowdown when you've got lots of failing events. But the thing that we've noticed is that the performance is generally adequate. We haven't had situations where we've had we've observed this in production where we've had mass failures across our infrastructure and stuff that we've hosted on AWS and things like that. We've noticed that Flapjack does a very, very good job of keeping up with any sort of large scale failure.
You can run multiple processor instances as well, which we're now doing if it can't keep up with the event processing load.
Yeah, so the key point there is that because we are currently shipping the omnibus packages with Ruby 1.9, so it's a C Ruby, it's single-threaded. That sort of sucks. So that means that even if you've got lots of cores on the machines, it's not going to matter because you're going to be tied to a single core at any point in time. So we did an upgrade very recently. We noticed the performance wasn't matching our expectations. As a short-term fix for that operationally, we just fired up another copy of the processor, and it was able to deal with the excess load fairly easily. So basically, you can, as a general rule of thumb for deploying Flapjack and making sure that it's you're optimizing for the throughput of event processing, fire up a Flapjack processor for every core that you've got in the machine. Maybe -1 because Redis also takes up a core. But yeah. All right. Any other questions? All right, no worries. If you have any other questions after this, you can come find us for the rest of the day here. We're also going to be at the post-Monitorama monitoring meetup. Say that 5 times very quickly, at Jive Software tonight at 18:30. And it's post-Monitorama isn't after Monitorama, not post-modern, so. Anyway, you should totally come along to that, and otherwise just come up and say hi to us. Thank you very much.
We've also got stickers.